SAT Questions of the Day, Week 1. These were a little bit blurry at times, but we'll do the best we can. If the quantity x minus 1 divided by 3 is equal to k, and k is equal to 3, what is the value of x? So the first thing we have to do here is substitute k equals 3 in for k. And once we do so, we're left with a two-step equation. We can multiply both sides by 3, cancels out. And then we're going to add 1 to both sides, and hopefully we chose D. Number 2 is a word problem, one of a whole bunch of problems that involve interpreting linear equations. So Kathy is a repair technician for a phone company. Each week she receives a batch of phones that need repairs. The number of phones that she has left to fix at the end of each day can be estimated with this equation. P is equal to 108 minus 23D, where P is the number of phones left and D is the number of days she has worked that week. What is the meaning of the value 108 in this equation? We'll think about a traditional y equals mx plus b equation. M is our slope and b is our intercept. But what does that actually mean? The slope is the rate of change, and this other number is a constant value or a starting value, sometimes called an initial value. If we look at this equation here, there's a number that changes once we plug in d, that's 23, and there's a number that is a constant, that's our initial or starting value. So the 108 means b, how many phones we start out with each week. 3, a similar type problem, linear interpretation. A pediatrician uses the model above to estimate the height h of a boy in inches in terms of the boy's age, a, in years between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? So that keyword each year tells us we're looking at the rate of change. The rate of change is another word for slope. So the answer is just 3. It's as simple as that. Of course, you could plug in some different numbers between the ages of 2 and 5 and figure out that, hey, it's only going up by 3 each year. That's the long way. Number 4, if a over b is 2, what is the value of 4b over a? So one way to solve this would be to solve for a variable, like maybe I'll multiply both sides by b, canceling out on the left. And now that I have a is equal to 2b, I can plug this in on my other equation. So 4b is now divided by 2b, which you can just get an answer. That's just 2, which is the answer. Of course, if that doesn't really make sense for you, you could have just picked two numbers. Say a is equal to 4 and b is equal to 2. Because after all, if you plug those in, 4 divided by 2 is 2. If you tried it over here, 4 times 2 divided by 4, you're going to get 8 divided by 4, which is also 2. So if the algebra part didn't make sense, you could have just picked some numbers and plugged them in. Number 5 is a straight systems problem, not a word problem, no interpretation, just solving it by substitution or elimination. Substitution would probably deal with this bottom equation. I might add x to both sides and add 19 to both sides. If I did so, I'd end up with 2y plus 19 is equal to x. And then I could take this whole thing and plug it into the top equation for x. And now I've done it. I've gotten rid of the second variable. I'm down to one variable. It's a little bit of math, but I can figure out what y is. I have to distribute the 3 to both terms, combine like terms, subtract 57 from both sides, and once I divide by 10, I get my answer that y is equal to negative 8. There's only one such answer, where y is negative 8. Let's say I wanted to solve that same system with elimination. Well, the first thing I might do is rewrite this second equation, just change the order. You can do that since you're adding and subtracting. And it depends which one I want to cancel out. Let's say I choose to cancel out the y's. So I might double that entire second equation. So I took negative 1 times 2, 2 times 2, and negative 19 times 2. And now it's double. So since I have two equations that have the same coefficient for y, I can subtract all 3 columns straight down. 3 minus a negative 2x gives me 5x. 4 minus 4 gives me 0y, and it cancels out. And negative 23 minus a negative 38 will give me 15. Divide by 5 on both sides, and x is equal to 3. Still b. Both methods work. I suppose if you forgot how to solve a system, you could plug numbers back in, but there are so many systems problems on the SAT and PSAT that you really should learn these methods. Number 6 involves a piecewise function of sorts. So John runs at different speeds as part of his training program. The graph shows his target heart rate at different times during his workout, on which interval is the target heart rate strictly increasing, then strictly decreasing. So if you look at this graph, there are times when the heart rate is going up. I'll mark them here in red. There are times when it's kind of flatlined here in blue. And there are times when it's going down here in green. Oh, and it looks like I missed a few. Going up here and flatlining there. So let's look at some of the answer choices. Between 0 and 30, I go up and I'm flat. That's not it. Between 40 and 60, I go up and then down. That's a strong candidate. If you look at choice C, between 50 and 65, I go down and then up. So that's backwards. And choice D, I go up and then flat. So it looks like B was the best choice. That is the only interval where it went strictly up and then strictly down. This graph of the quadratic x squared minus 2x minus 15 has two solutions. The solutions are where the graph crosses the x-axis, or the zeros. So our solutions here are x equals -3 and x equals 5. When we factor this quadratic, we get answers that look like these. To figure out the zeros, we should be able to plug in -3 and 5 and get 0 for parts of this equation. So if we look at choice B here, if I plug in -3, does that give me 0? No. It's going to give me -6 or 10. It's not going to give me zeros for either one of these either. But if I plug in -3 to this first factor and +5 for the second factor, A gives me two solutions. You could have also paid attention to when you multiply these last terms, 3 times -5, you get -15 here. That would have ruled out choice D at least, because all the others have a -15 for the constant also. Number 8, Jessica opened a bank account that earns 2% interest compounded annually. Her initial deposit was $100, and she uses the expression $100 times x to the power of t to find the value of the account after t years. So if you want to multiply something by 2% or earn 2%, what you do is you take the original 100% plus 2%, and you're at 102. Then we're going to take our decimal and move it to the left twice, and 1.02 is what we multiply by. Kind of like if you're multiplying by 1.06 in Michigan to find out the sales tax. So the actual answer is 1.02 because the equation would be 2% interest for every year in t years. We're just looking for this part here. Whether you're earning or losing some percent compounded annually, you can always start with 100, add it or subtract it, and move the decimal place twice over. So here Tyshawn, Jessica's friend, made a $100 initial deposit, and he's got an interest rate that earns 2.5%. So I would take 100 plus 2.5, get 102.5, and I'm going to move the decimal place to the left twice, which means my interest rate is 1.025. And they want to know after 10 years, so we're going to put this to the power of 10. So this gives you 128.008. But that was just Tyshawn's savings. If you compare that to Jessica's, who earned the 2% interest instead of the 2.5%, over the course of 10 years, and you round these to dollars and cents, you can subtract the two, subtract these two numbers, and you'll get $6.11. And that's your answer. Number 10 says, which of the following graphs best shows a strong negative association between D and T? So generally speaking, a positive association would head in this direction, and a negative association would head in this direction. And if it's a strong association, then the dots will be kind of close to the line. Where if it's a weak correlation, they'll kind of be all over the place. That's more like a no correlation to me, but somewhat weak, I suppose. So we're looking for something that goes down and kind of makes a line. There's our best choice. A might be somewhat negative in a trend, but it's not a strong association because they're all over the place, where this fits the pattern better.